Okay, so the today topic is on arrays. Okay, so why do we need arrays? So let's say you want to take 100 numbers from the user and you want to take their sum and average. So far how you will do it? So what you will do that you will declare a number. You will ask the user to enter number. And number two, and number three, so on and so forth. So you need to declare 100 variables and then take the value of each variable. So let's say int num 100, and then what you will do, you will take the sum of all of them. Take that way. So okay, so you can imagine that you have to store the same data, but you have to store it in different variables, 100 variables, and you have to get the enter from the user in the 100 input, and you need to then some of them, and then you need to take the average. So it's a very inefficient um, way to store data. So is there any better way to do it? Yes, so we could have used using arrays. We can store same type of data. Let's say int number 100. That's it. And then we can use a loop. Int I is equal to 0, I is less than 100, I plus plus, print f, enter number I. Scanf, and then you can get all the data, and then might be you can do the summation in the loop as well, and then at the end you can get the average. So you see, it's a very compact code and much better way to store the data. Okay, so this is the reason why we are actually studying loops. Okay, let's see if we are going to have some intro to arrays, array declaration, how you are going to use loops with arrays, and then we will be discussing about the types of arrays. Okay, so before we move to the arrays topic, so let me tell you some of the things that is really important. So let's say, so far what you have been doing, so we have taught this before. So here is the memory view. So A will how much location A will use? 1, 2, 3, 4. And the B can be used anywhere, right? So this is A and this is B, right? Now what happens when you do int number, let's say 4? It's an array. So what we are doing, oh sorry about that. So let's say we have to store int A is equal to 2 and B is equal to 3. Okay, so we need to, this is A is equal to 2 here, and then B is equal to 3. It could be anywhere, right? Doesn't have to be in the same contiguous location. So, but what happens with arrays, number 4? So how many elements it will have? Numbers 0, it starts with first index. Numbers 1, numbers 2, and numbers 3. Okay, so let's see how it is stored here. So this is number 0, and then right after that, here numbers 1, numbers 2, so numbers 3. So all the memory locations are assigned in contiguous. So it is contiguous memory location. Okay. So for variables, maybe non-contiguous. It could be random, but for array it has to be contiguous. All right. So array declaration. So array must be declared with this type and size. They can be initialized at time of declaration or later. Okay. So this is really important. So this is the declaration part, and this is the initialization part, and this is declaration plus initialization. So let's say, like in the memory, for like number 0 is equal to 1, so how it will store it? 0x01, 0x00, 0x00, 0x00. For the second one, here it will be 0x02, 00, 00, 00. And likewise 03, 00, 00, 00. So this is number 0. This is number 1. So this is how it is stored in the memory. But you can declare it and then you can initialize it, or you can declare and initialize at the same time. Okay, one more important thing that you need to know about this thing. So let's say I want to get, let's say, the numbers from the user. Let's say user needs to enter the numbers. So let me select my blue pen. So let's say user want to enter the number. So let's say number of students. Or we can say number of students. And here also you need to see number of students. Okay. And then we need to see int marks number of students. We need to take the marks of each of the student. And then we can so int I is equal to 0, I is less than number of students I plus plus, and here you might have to ask the user to enter the enter marks of student percentage I. Scanf percentage D, address of marks I, and maybe you can just add a student mark, take the average afterwards. Okay. Now, how many of you think that this is okay? So there is some fundamental problem here, and this is something I need to talk about a lot about this, so you need to be very careful. So okay, so let's say int marks number of students. This number of students has to be constant. So array can be declared at compile time. What does it mean? Array size should be known because compiler has to allocate memory. So if you don't know the size of the array, we won't be able to do it. So there will be can be two ways to do that. So one is, the way the size should be, there might be number defined n 100. So there is no semicolon, just number defined 100. And then what you can do, int marks n, and then might be you can write on and I is equal to 0, I is less than n, I plus plus, and enter the student marks, add it, and so whatever you want to do. And let's say if you want to next time you want to change it to instead of 100 you want to change it to 200, you just specify it over here, and then everything wherever you have used 100, it will get replaced, and then will be replaced by 200 in all those locations. Okay, so this is one way. The other way is int main. You can use constant int n is equal to 100, and then int marks n. So both are equally important, but the point that we need to talk about is that the array size has to be known at compile time. So you cannot get the array size from the user. We will see later how we can get the we can declare the arrays based on this input that we take from the user. But for now, let's just assume that you need to know the size of the array beforehand. So you can specify the size using number define n to 100, and then but we just have to change it once, and then it will just get replaced all the time, but you have to specify it. Okay, this is really important. Okay, so how do we access the array element? So array name index. Okay, so let's say I want to access the third element, so int value is equal to numbers 2, and so how to use arrays in C? So I think here we have declared array of 5 elements, 2, 3, 5, 7, 10. And just access and modify the value at index, and this is 0th index, this is 1 index, 2 index, 3 index, 4 index, and we are modifying the element at index 2 is actually the third element. Okay, and then we are just printing the array, so we can access the variable using array I. Okay, so we can perform all sort of operations on the arrays, summing, maximum, minimizing, sorting. So we can sum all the array elements using this. Sum equal to sum plus variable I. All right, and then we can figuring out the maximum value of the array. Okay, so the next important thing that we need to know about is single dimensional array and multi-dimensional arrays. Okay, so before we move into the single dimensional multi-dimensional array, so this is really important. So let's see, so int vector. So So let's say it's a 10 element vector. So how it will be stored? So let's just keep it simple. So let's say it's a 3 element vector. X, Y, Z, let's say. So this is a vector 0, vector 1, see the index 3 but 0, 1, 2. Okay, it's a contiguous multiplication, so it's 1D array. Okay, so let's say if I want to do, let's say, a matrix. So let's say it's 3 cross 3. Okay, so how it will be stored? Okay, so this will be matrix, the first row 0, 0, 0, 1, 0, 2, 1, 0, and so on and so forth. So you see, the first row will be stored, and then so it's you can say first row, second row, and then the third row. So you know the memory itself, although it's a two-dimensional array, but the memory, our memory is 1D, so we have to store it in multiple 1D arrays. So each first row, second row, third row, so on and so forth. Okay. So this is the single dimensional array that I have already talked about. This is the multi-dimensional array. Great. Okay, so let's say this is the two-dimensional array, matrix 2 and 3. So it's this the 2 rows and 3 column. This is row 1, row 2, column 1, column 2, column 3. Okay, so how do you initialize it? So you can specify it in multiple rows. This will go to row 1, this will go to row 2. Okay, so so we have initialized it, but then now let's say I want to modify this. So if I assume matrix 0, 0, it means that after this should be moved to 10. 1, 1, so it's row 1, column 1, so this should be updated with 20. Row 0, column 2, 30. Sorry. Alright. So let's say we want to update with 0. So how do we access multi-dimensional arrays? So we have to use nested loops to process the arrays. So let's say this is for entire 0 I less than 2. So this is for rows, and this is for columns. So let's say this one. So you need to first take the row and then print all its columns. Okay. Then you print all the columns. And then you move up and then take the next row and print all the columns. Okay, so I think we have covered the arrays in detail. So let me just tell you, how do you use arrays in different applications? All right. 1D array, 2D array, 3D array. So all your signals, you can represent them using arrays. Let's say speech, let's say temperature. If you have to, this is time and this is some value. Of course, you need to digitize it. Then you need to store it. So let's say speech signal. It could be like 1000 samples of your speech signal. Or temperature, let's say 1000 values of your temperature. So you need to specify it in, or it could be vector, 100-dimensional vector, taking floating values. So these are, you need to use arrays to store these sort of signals. In 2D, your matrix, you have to use 2D array to store the matrices and all the operations they need to perform. Image, let's say grayscale image. So it has to be 2-dimensional. Let's say 3x4. Sorry, 4x4. And here it was just a 1-dimensional thing. Here is 2-dimensional. So what about 3D? It could be RGB image. Okay, so what do we mean by 3D? So this is red image, G, same, and B. So if you have to use it, then so for this one, let's say int matrix rows columns. For this one, it could be int RGB image, or it could be unsigned character RGB image. So this is 3, and this could be 640 across 480. See here. So these are the different applications of arrays. Okay, with this I conclude my lecture on arrays.